How's it going, everybody? I want to go over a little Lab 10 specs, and basically we're going to have a little rundown of what we want to do. Basically, I'm using an online compiler, and I just typed this in straight up without HTTP, make it a little easier instead of working Visual Studio right now. And I want to be able to work this here with the lab. One thing to note, if you ever want to refresh the screen a little bit, I would clear the history and sort of refresh this here, so easier to start at the beginning. But you can always, of course, key things in and mod things along the way, and it should be fine to rerun. But if you ever want to go back to the original screen, I would do that. Okay, so after reading this, we want to do an n-by-n matrix, and basically we want to run through things here enough so we can take you up to the first few modifications that you would have to do to get a comfortable run. So I'm going to grab this here and just sort of key this right in. And if I do a run, excuse me, I want to sort of see how this runs, and we get maybe some starter information that we can go off of. So first row, first column, first row, second column, and then second row, first column, second row, second column. And we get the little indices so we can sort of have the programmer follow along the logic. So this runs fine. Now we want to go up to that modification here to sort of mod the array size, because we want to be able to have up to 100 rows and columns. So obviously we want to allow for the user input for that. So please make sure we put something in to allow for that, and you would have to tweak your loops to do that, so it's not just 2 size. So you could put in a variable for m to allow for m for rows, and then n variable for n columns, and you would have to then tweak the size differences here for what the user enters. Okay, doke. Now we want to get a trace going, and basically a trace, what that does, it's going to be allowing for diagonal computation. So we're going to add every time this here. If I'm a 2x2, if I'm a 3x3, we go across each row, across each diagonal portion of the column. So as I grab a new row, I grab the column position that would be considered diagonal. Of course, this is the first row, and I have to grab that first value because that's from left down to the right size as the position. So if I go to the next row, the diagonal is going to be shifted over. Similar logic here. Start at the first position, second position diagonal, third position up to n number of positions there to grab the trace. So pretty cool. So how would I do that in code? Well, I can put in a trace here. We call it trace. And I need to obviously add values along the way, so I got to sort of summate that, put that in a bucket, accumulate those values. So I'm going to sort of maybe look at here the action for transposition. Remember, we're going to go to so many rows, and each time I go through so many rows, I have X amount of columns to go through. So I make that distinction here. And I want to put my trace in here. I notice that I can grab the array A at position I and J as I go through input, and I even show you the transposition portion there. Okie doke. So now, let's see if I can grab the trace, and then I'm going to display the trace. So if I say trace equal trace, so I want to accumulate that, plus portions of that array that are pulling the diagonal values. Now if I just start with this and run it, and then show maybe the output of this, maybe after the loop is over, here's the trace. Well, what's going to happen? Let's say if I did that 8 and -2, -7, and 1. I'm going to get 0. Oh my gosh, that's not 9. So something here has to be adjusted, obviously. I would have to pull some conditional logic. So what I'm going to do is say, add in conditional logic. And what do I mean by that? Well, we want to go ahead and say see by, or check by position, check by diagonal position. Whether to add trace. Whether to add to trace. And what is the secret? Well, I'm going to go by I and J's. Now notice this transposed it obviously here from what the original positional logic was. So I could take advantage of that, and I could then check with an if statement, yeah? And see if I am going to, at the diagonal point, add I and J position value to trace. That's the key. Okie doke. And once I get that working, we show you this here, but it's not completely correct, of course, because it zeroes out, obviously, as I go through the values, as I pointed out to you here, 8 and 1, but really what happened was it also added the -2 and -7 to zero out. We don't want that. Okie doke. So the third part would be work determinant, and you can really have an if statement plugged in, and you can go by position here as shown. We can work a determinant, you can call something a determinant at these positions and say, okay, is something beyond a 2x2? Well, I can't give it a determinant if that's the situation, so we'll just keep it easy. Of course, we could do 3x3s and so on and so forth. This is a good site I'll plug in for you that shows basic determinant logic from Math is Fun. I'll give you that link when I send you the video on YouTube link, okay? So that would be something that we want to sort of say what would be a determinant. Determinant. And we would want to put the determinant somewhere once we know what the I and J position for a 2x2. So after I get this 2x2, let's say, entered, I can then put in the determinant. What would that be? Well, it shows you, here's what a determinant is. I have array A, and I have position here multiplied out at 0, 0 times, and I'm assuming this is for 2x2 because that's what the requirements say. I'm not doing a 3x3, anything complex like that, so grab those values there at these positions. Okay, and subtract that out by the opposing positions listed. So grab this, put this in a parenthesis just in case, and bada bing, bada bam, put that in there. Do a little tweakaroozy because I'm now doing position 0, 1 as opposed here at 1, 0. So I can then ask the question later on at some point, if we don't have a 2x2, if let's say I is not, or whatever, let's say you have a variable m, if m is not equal to 2, and somebody keyed in maybe n value, if that's not equal to 2, well, we don't have a determinant, so no determinant. Well, obviously, if it was true, then we could say else. And we could say the determinant is whatever that calculation was. And what does a determinant do? Sort of gives you this calculation. So it's doing this and this combined. Let's see what we got. It's giving you these guys multiplied out, right, at position 0, 0 and 1, 1, which is actually this here, my bad, subtracted by this guy times this guy. And whatever that calculation may be, determinant equal that 8 times 1 and subtracted by the negative 2 times negative 7. Oops. Okay, so it's 9 time minus the values here, which is 14. So what would be that determinant? So that should give me that outcome. 8 times 1, which is 8, subtracted by negative 2 times negative 7, which is positive 14. So 8 minus 14, what does that yield? Minus 6. Else determinant is so I think it's giving you some good logic. Good luck. It's a cool lab, and I hope you enjoy. See you soon.